Hello guys, I hope everyone is good. Today we are looking into the squeeze theorem. This is your calculus A from Jacob. Okay, let's get started. So we will quickly go through some important aspects or information on this chapter. So your squeeze theorem, we are using it into two types of functions, which is your polynomial function and trigonometric function there. So never mind the spelling of function there on trigonometric, it's spelling error. Okay, so this is if you have an inequality of three functions like this. If you have f of x less than g of x less than h of x, and if I calculate the limit of the left hand side and the limit of the right hand side, if those two limits are equal, which means the limit as x approaches a of f of x is the same as the one of h of x, L, then it means the limit of g of x is also L. This is the same as saying, remember if I have a function of x, if I say it's less than 1, let's say, but greater than -1, it means your answer is anywhere between -1 and 1. But now if I say the same thing, if I say it's between 1 and 1, there's nothing between 1 and 1, so which means the answer is definitely 1. So that's the same principle there. So if I calculate the limit this side, then I get 4. Then I calculate the limit this side, I get 4, which means the limit of this is also 4. So that's the principle we are going to use. So now let's quickly discuss the polynomial function. So with polynomial function, if we have the same formula again, three functions, then I calculate left limit and right limit, and the answer is the same, then it means the limit of the middle function is also L, which is exactly what I was explaining. The only difference comes with trigonometric. The principle is the same. At the end of the day, we have to calculate the left limit and the right limit. But with trigonometric, you should know we apply only these two inequalities, that your sine is between -1 and 1. Also your cos, if you remember your sine graph and cos graph, the amplitude, it reaches the maximum range of 1 and -1 there. Even your cos is the same thing. So this is where the principle is from, -1 and 1 there. So the value of x here doesn't affect your amplitude at all. It doesn't affect the amplitude. So they can give you, they can say sine 10x, it won't affect the amplitude. These answers will be -1 and 1. So anything else they give you, for example, if they say 1 plus sine, we know if they say 1 plus sine, it means this graph of sine, it's moving 1 unit upwards. You see, it means instead of 1 here, it will fluctuate between 2 and 0. What happened? They added 1. If they say 1 plus sine x, it means you must add 1 everywhere. So if I add 1 this side, I have 2. If I add it this side, I have 0. Then now I must calculate the limit of 0 and of 2. And if they are the same, that will be the limit of sine. But you will see when we do questions. I just want to explain how we are going to use this sine and cos. So if you check most question papers, in fact all the question papers I've seen, there's no polynomial functions. There is trigonometric functions mixed with polynomial, but they all apply these trigonometric rules. But you will see with questions. So I'm gonna do just one question for polynomial from the study guide, then we do one also for trigonometry, then we do few questions from the question paper. Okay, let me pick any function. Let's say I have a function of 2x squared. This is from the study guide. Okay, I made a mistake. It's just 2x squared. 2x squared over x squared plus 1. And they're saying it's less than f of x less than 2x squared plus 5 over x squared. The question here, they say find, let me write the question here, find the limit x approaches infinity of f of x. So what does it mean? Our solution now, it means we must calculate the limit on the left hand side and the limit on the right hand side and see if we get the same answer. So let's start. So the first thing we are going to do is we calculate the limit on the left hand side, which is x squared plus 2x squared over x squared plus 1. So how do we calculate this limit? If you remember your basic limits, if you can see, if I substitute infinity at the top, I'll have infinity over infinity, which is not something we don't want. So but we know if you're dealing with polynomials, you must always take out the one with highest exponent at the top. If I take out x squared, I'm left with 2. At the bottom, if I take out x squared, I'm left with 1 plus 1 over x squared. Don't forget your limit. That's why I left space here. Then now what happens? X squared and x squared cancels. So now I'm left with limit x approaches infinity 2 over 1 plus 1 over x squared. So now we can see the answer will be 2 over 1, which is 2. Because this limit 1 over infinity is 0. So your answer will be 2 over 1. Okay, now we have to do another limit of the right hand side. So the limit of the right hand side, we have 2x squared plus 5 over x squared. There. 2x squared plus 5 over x squared. Okay, so if I calculate that, I'm doing the same thing. I must take out my highest power at the top and bottom. So I have x squared. So here I'm left with 2 plus 5 over x squared. At the bottom, I just have x squared. So we can see x squared and x squared cancels. So now I'm left with 2 plus 5 over x squared. So what's the answer? It's 2, because 5 over x squared will be 0. This one will be 0. So do you see these two limits are the same? So therefore it means the limit of f of x when x approaches infinity, it's also 2. So this is how you'll be doing. You use the squeeze theorem. It's 2. So the squeeze theorem, it's also another name. I had another name. I saw another name in there. It's also called a sandwich theorem. It's like your function is sandwiched between two functions. So if those two functions are equal, it means everything is equal. Okay, let's go to trigonometry. So here, let me pick one function. Okay, I think I saw one. You have okay, I'll pick this one. They said determine okay, where is it? What's the function? Oh yeah, determine the limit of x approaches 0 for x squared sine 1 over x. There, determine that limit. I hope I'm checking the right. Yes. So now remember, this is sine. Remember, we have two functions. We have your sine between -1 and 1 and your cos. So this time they gave us sine. So check, the only difference is that now instead of 1 sine something, we have x squared. That's the only difference. Here we have 1 1. Remember, this x, it doesn't matter what value it is, it doesn't affect your limit, because the limit has to do with range. How far in terms of y does your function go? So this only affects the period, which is your x. But this one before your sign, it's where your -1 and 1 comes from. So here, if I have x squared, this is where you check what did I do to get x squared, because now you start by writing your graph without the x squared, so which is, I mean, your function, your inequality, which is -1 less or equals to sine 1 over x less or equals to 1. So now what did they do for them to get to x squared? They multiplied by x squared everywhere. So they multiplied by x squared everywhere. That's what you are going to do. If I multiply -1 by x squared, I get minus x squared. If I multiply sine, I get x squared sine 1 over x. If I multiply 1, I get x squared. So now I have that function exactly the one. So what should we do next to calculate the limit when x approaches 0 of your left hand side, which is minus x squared? You can clearly see we're getting 0. Now calculate the limit when x approaches 0 of the right hand side, which is also 0. What does that mean? It means therefore the limit as x approaches 0 of x squared sine 1 over x is 0. That's what it means. Just like that. So, but with exams, they make it more complicated. They don't just say x squared. They can say 1 plus x squared. But you will see the next two slides we are doing it's exam questions. So here's the first one from November 2019. They say calculate the limit of that of 5k squared plus sine 3k 10 minus k squared when k approaches negative infinity. So let me make space on my board there. So remember, the first thing you're going to write is your general inequality, which will be sine 3k, because we check our what we have. So sine 3k between 1 and -1. So now can you tell me what did I do to get 5k squared and divided by 10 minus k squared? So you do it step by step. You don't rush. You can first start by dividing, but the easy way, you can't divide because divide is for everything. So you start by adding 5k. So that's the first thing they did. They added 5k squared there. So now if I add 5k squared, what do I have? I'll have -1 plus 5k squared. Okay, I think I won't have space. So let me write it here. If I add 5k squared to -1, I'll have 5k squared minus 1. If I add it to sine, I have 5k squared plus sine 3k. Okay, this is inequality less. If I add it to 1, I have 5k squared plus 1. Then we are done with that step. The next step is what? Divide. They divided by 10 minus k squared. You see, we are doing it step by step. So now divide 5k squared minus 1 by 10 minus k squared. Divide that sine. We get 5k squared plus sine 3k over 10 minus k squared, which is exactly what we wanted, right? So which means this is our last step before we calculate. I hope this is clear. So the first thing we checked from your normal sine, what did they do? They added 5, we added 5k squared. They divide, after that, they divided by 10 minus k squared. So now all we have to do is to calculate the limit as your k approaches negative infinity. So we start with the left hand side. We have 5k squared minus 1 over 10 minus k squared. Remember, again, you take the number with the term with highest exponent, which is k squared. If I take out k squared, I'm left with 5 minus 1 over k squared over, even at the bottom, if I take out k squared, I'm left with 10 over k squared minus 1. So now I hope we can see the answer from here. I don't want to take too much space. So if I'm going to substitute my negative infinity squared, this will be 0, this will be 0. So my answer will be 5 over -1, which will be -5. So we do the same thing on the right hand side, and our answers should be the same. So this time we're calculating for 5k squared plus 1 over 10 minus k squared. So we repeat, we take out k squared as common, so we are left with 5 plus 1 over k squared. At the bottom we have 10 over k squared minus 1. So you can see again what happens. K squared will cancel. 1 over k squared is 0, 10 over k squared is 0. So we have 5 over minus 1 again. So your answer is minus 5. So therefore you conclude, therefore it means the limit when k approaches negative infinity of 5k squared plus sine 3k over 10 minus k squared, it's minus 5, just like that. And you see how many marks? This is 5 marks. This is 5 marks, and it's 5 marks you shouldn't lose because it's not too complicated. Okay, the video is already too long, 16 minutes, so let me do last question. Okay, let's do this one. So again, with this one, you start from the beginning by writing your standard formula. So let me make space. So if I write my standard formula, I'll have minus 1 for cos what? Cos k cube between minus 1 and 1. So the first thing, what did I do? Before, remember this cos is positive. So before we even add 5, do you see cos? It's negative there. So which means we must first multiply by negative 1. That's the first step to make that negative cos. So if I multiply negative 1 by 1, I'm getting 1. Remember this sign, if you're multiplying everything by negative, this sign will also change to be the opposite way. This is cos 3k. This sign also changes to be opposite way, and the 1 becomes minus 1 there. So now what's the next step? The next step is add 5. Now you add 5 both sides. If I add 5 to my 1, I'm getting 6. If I add 5 to my cos, I'm getting 5 minus cos 3k. If I add 5 to my negative 1, I'm getting positive 4. Then the last step is divide by what? Divide by k squared plus 5. That's my last step. So I'll write it here. So I'll have 6 over k squared plus 5 equals to, not equals to, greater or equals to 5 minus cos 3k over k squared minus 5. Okay, this is minus or plus 5. Then greater or equals to 4 over k squared plus 5. So now when we are here, as long as this term here is exactly like the one we want, then now we calculate our limit. So let's calculate. So we have to calculate limit of as k approaches infinity of the left hand side, which is 6 over k squared plus 5. So now if you check, we cannot take out k squared as there's no need to take k squared as your common. Even if I take it out as my common, I'll show you here. If I take it out as my common, at the bottom I'll have k squared, I'll have 1 plus 5 over k squared. Then at the top I have 6. So what happens? This is not cancelling, so what's the use? Because now if I'm going to substitute, I'll have 6 over infinity, which is my k squared, 1 plus 0. So do you see? Either way we will have infinity at the bottom. So we might just as well substitute. As long as it won't cancel with anything, then leave it as it is. So now if I substitute, I'll have 6 over infinity plus 5, which is 6 over infinity. Anything over infinity is 0 because infinity is a big number. Then I do the left hand side also. 4 over k squared plus 5. The answer will be what? 4 over infinity, which is 0. So therefore my final answer is limit x approaches infinity. It's what? It's of 5 cos k cube over k squared plus 5 equals to 0. That's your answer. 4 marks there from June 2019. I hope this was clear. Okay, thank you guys. I'll see you next time.